CHEE is an interface standard developed by the Wireless Power Consortium for inductive electrical power transfer over distances of up to 4 cm. The CHEE system comprises a power transmission pad and a compatible receiver in a portable device. To use the system, the mobile device is placed on top of the power transmission pad, which charges it via resonant inductive coupling. Mobile device manufacturers that are working with the standard include Asus, HTC, Huawei, LG Electronics, Motorola Mobility, Nokia, Samsung, BlackBerry, and Sony. The Wireless Power Consortium was established in 2008, and is an open membership cooperation of Asian, European, and American companies in various manufacturing industries. Their aim is to create a global standard for inductive charging technology. Features and specifications. Under the CHEE specification, low power for inductive transfer means a draw of 0 to 5 W. Systems that fall within the scope of this standard are those that use inductive coupling between two planar coils to transfer power from the power transmitter to the power receiver. The distance between the two coils is typically 5 ohm. It is possible to extend that range to at least 40 mm. Regulation of the output voltage is provided by a digital control loop where the power receiver communicates with the power transmitter and requests more or less power. Communication is unidirectional from the power receiver to the power transmitter via backscatter modulation. In backscatter modulation, the power receiver coil is loaded, changing the current draw at the power transmitter. These current changes are monitored and demodulated into the information required for the two devices to work together. The WPC published the CHEE low-power specification in August 2009. The CHEE specification is available as free public download. In 2011, the Wireless Power Consortium began to extend the CHEE specification to medium power. The low-power specification delivers up to 5 watts. The medium power specification will deliver up to 120 watts. Adoption. As the CHEE standard gains popularity in the mainstream, it is expected that CHEE hotspots will begin to arise in places such as coffee shops, airports, sports arenas, etc. The major U.S. coffee chain The Coffee Bean and Tea Leaf will install inductive charging stations at selected major metropolitan cities, as well as Virgin Atlantic Airways, for United Kingdom's London Heathrow Airport and New York City's John F. Kennedy International Airport. Tulsa International Airport has already implemented chargers in half of the airport. System overview. Devices that operate with the CHEE standard rely on electromagnetic induction between planar coils. Two kinds of devices are at use: the base stations, which provide inductive power, and mobile devices, which consume inductive power. The base station contains a power transmitter that comprises a transmitting coil. The mobile device contains a power receiver holding a receiving coil. Close spacing of the two coils, as well as shielding on their surfaces, ensure the inductive power transfer is efficient. Base stations typically have a flat surface referred to as the interface surface on top of which a user can place one or more mobile devices. There are two methods for aligning the transmitting coil and receiving coil in order for a power transfer to happen. In the first concept called guided positioning a user must place the mobile device on a certain location of the base station's surface. For this purpose, the mobile device provides an alignment aid that is appropriate to its size, shape and function. The second concept referred to as free positioning does not require the user to place the mobile device in direct alignment with the transmitting coil. There are several ways to achieve free positioning. In one example, a bundle of transmitting coils is used to generate a magnetic field at the location of the receiving coil only. Another example uses mechanical means to move a single transmitting coil underneath the receiving coil. A third option is to use a technique called multiple cooperative flux generators. Figure 1-1 illustrates the basic system configuration. As shown, a power transmitter includes two main functional units: a power conversion unit and a communications and control unit. The diagram shows the transmitting coil generating the magnetic field as part of the power conversion unit. The control and communications unit regulates the transferred power to the level that the power receiver requests. The diagram also demonstrates that a base station may contain numerous transmitters, allowing for multiple mobile devices to be placed on the same base station and inductively charge until each of its batteries are fully charged. Finally, the system unit in the diagram comprises all other functionality of the base station, such as input power provisioning, control of multiple power transmitters, and user interfacing. A power receiver comprises a power pickup unit, as well as a communications and control unit. Similar to the power conversion unit of the transmitter, Figure 1-1 illustrates the receiving coil as capturing the magnetic field of the power pickup unit. A power pickup unit typically contains a single receiving coil only. Moreover, a mobile device typically contains a single power receiver. The communications and control unit regulates the transferred power to the level that is appropriate for the subsystems connected to the output of the power receiver. These subsystems represent the main functionality of the mobile device. Wireless Power Consortium. The WPC's mission is to create and promote wide market adoption of CHEE, the international wireless power standard for interoperability across rechargeable electronic devices. Established in 2008, the WPC is an open membership cooperation of Asian, European, and American companies in diverse industries, including electronics manufacturers and original equipment manufacturers. WPC is working toward the global standardization of wireless charging technology. The WPC standard for wireless power, called CHEE, creates interoperability between the device providing power and the device receiving power. Using the CHEE standard, a range of mobile electronics will be able to use magnetic induction to recharge simply by being placed on top of a single power transfer pad. History: established December 17, 2008. The WPC is in the process of creating a universal wireless power charging standard that allows electronic products and charging stations to be compatible with one another. Founding member companies include Convenient Power Limited, Fulton Innovation LLC, Logitech SA, National Semiconductor Corporation, Royal Philips Electronics NV, Sanyo Electric Company Limited, Shenzhen Sangfree Consumer Communications Company Limited and Texas Instruments Incorporated. In 2009, Nokia joined the WPC. Huawei and Visteon became members of the WPC in 2011. The WPC published the CHEE low-power specification in August 2009, named after CHEE, the Chinese language word for air or spiritual energy flow. In 2011, the Wireless Power Consortium began to extend the CHEE specification to medium power. See also, PMA, a competing wireless power standard promoted by Power Matters Alliance, RESENC, a competing wireless power standard promoted by the Alliance for Wireless Power, Repower, Contactless Energy Transfer, Inductive Coupling, Near-Field Communication, References. External links: CHEE Euro official site. Is CHEE ready to be the standard for wireless power? Popular Science. Retrieved August 21, 2009. Hackman, Mark. Wireless Power Spec nears completion. News and analysis by PC Magazine. Retrieved August 21, 2009. Schofield, Jack. Is there a realistic future for power without wire? The Guardian. Retrieved August 21, 2009. http://www.qi-case.com, QI wireless charging cases for iPhone 5/5.